Hello, Piedmont families. We miss you. I am bringing you today's video science of the day, the Panther way. If you guys don't know who I am, my name is Mr. Apple. I've been in contact with our science teachers, and we are really missing each other because you guys, the students, bring us together. And like me, we are all somewhat lost in these uncharted waters per se. I am so grateful for each of you, but I'm also so grateful for each of them in the science department. So I dedicate this video to them. I call it, What If the Science Department Went on Vacation Together? Well, hey guys, we chose the beach. Yep, the science department chose to go on vacation at the beach. About 10 or 15 minutes, I may have to reapply, but I've got my swimmies, got my goggles. I'm feeling pretty good about myself. I'm enjoying my time out here in the ocean. Miss Darns drove us down here. It was a great trip. She chose to bring her camper, and we're all staying in it. She can drive that thing forward. She sure can't drive it backwards. I did happen to take my glasses out here to the beach so I can see out there a little bit more. I want you to look way out there, man. There is Doc on the beach. He's drawing organ systems in the sand, the skeleton in the sand. He's asking people if they know what it is. Doc, always planning the next lab practical. Up there, Miss Darns, way up there. Hey, Miss Darns, way up there on the hill. She's building a sandcastle. Talk about attention to detail. I don't think there's a teacher out there that knows her students better than Mrs. Darns. When I need to know about students, I go to her. Plus, she's always ready to do the right thing, and she is very diligent. Miss Harris, always conservationist, way up there. Gosh knows, got hit by a wave. Way up there on the sand dunes. Arms outstretched, standing on one leg. I suppose it's some sort of yoga pose, but she's a conservationist, keeping everybody off those dunes. Right beside her, hey, Miss Kazaya, ready with the camera in hand to record those sea turtles possibly making their way to the ocean tonight. I don't know. I sure hope it happens. Her marine class will sure dig that. Toes in the water, chairs in the sand, two good science books in their hand. There's Miss Fugate. I bet she's calculating the wavelength. Oh my gosh, another wave. The wavelength of the water hitting her on the shore. Miss Walker has stopped reading. There she is. She's counting red crabs, blue crabs. I think she's doing a Hardy Weinberg problem. Whew. Oh, well, have I forgot? Oh, Miss Griffin. That Miss Griffin, gosh knows that she has spunk. I have seen her walk up and down this beach, taking salinity samples every 100 yards. I think she's also calculating when the next high tide is going to be, possibly low tide. I don't know. She sure does have spunk. I don't think I forgot. Wait, I have forgotten somebody. I carried about all of his plaster down to the beach. Let me see. Can I see? There's Mr. Sweeney way over there. Look at him. Look at that man. He is actually taking plaster casts of footprints in the sand, using that forensic knowledge. I bet you he's going to solve the toilet paper caper. Piedmont science teachers are building their classrooms all the time. We miss you guys, but we're building our classrooms. I've been out here swimming. I've seen a few fish here. I've seen a few turtles here, a few fish here. And unfortunately, I've seen a lot of these. Oof. I don't know if you know this or not, but 1 million plastic bottles are purchased every minute. And only 14% of them go back through the recycling process. Well, some scientists out there have been trying to solve this problem, and many have come up with an idea. And they have actually found bacteria that like to feed on plastic. Yes, I know what many of you are picturing right now. Bacteria, prokaryotic cell, no more plastic. You're right. It does take a lot more than magic to break down plastics. I hope you were wondering, how does a bacterial cell break down plastic? Well, we know, like other living organisms, bacteria have the ability to produce an enzyme. And we know that enzymes, for scientific sake, end in ASE, and enzymes are catalysts for reactions. In other words, they speed up reactions that will probably already take place, but Much like it takes this plastic bottle 450 years to deteriorate, an enzyme can speed up that process. All right, here I have this enzyme. It is called PETase because the other name for plastics is polyethylene terephthalate. That's why we call it PET. So here is my small plastic, PET. It's got 2 subunits of plastic. The subunits of plastic, much like carbohydrates, contain carbon and hydrogen and oxygen. All right, so they make good molecules for energy production or to run processes within that bacterial cell. The enzyme comes in, binds to the substrate. You should all be familiar with those terms. Here's my enzyme, here's my substrate, and it breaks those PETs apart, and I'm left with a PET. Now, the cell can take this PET and use it for whatever biological process it needs. What does a PET look like? Well, here's what that subunit looks like. Remember, I said it was a carbon-containing molecule, much like glucose. Well, we use glucose in cellular respiration. These bacteria can use these PETs in whatever process they may need. We would love to be able to use this process in industry, and many scientists are trying to figure out a way. However, the process is in its early stages and not efficient enough to be used to take care of all the plastics that we have. Our best method currently is really to reduce, reuse, and recycle. Hey, wait, they're burying Doc in the sand. I gotta go.